All right, so let's begin. Secret, I'm so happy. Yeah, it happened every time I go on live the first time. Anyway, we'll figure it out why that happened. All right, so let's go. Let's take a look at linearization. I'll give you a couple examples. We'll at least try and do one with a graph today. Okay. Right, and that will end the series on logs, and I'll give you a test on logs next week, and then we move on. Yeah, test. How to get a test on logs. All right, that's not working, right? So you're looking at here or your phone if I share anything, right? All right, so you want to take a look at linearization. Just a quick reminder. What does the term linear mean? Right, linear basically means a straight line, right? And straight lines are generally of the form what? Straight lines are generally of the form y is equal to mx plus c. So we're going to learn now how to take any equation and make it into this form. Okay. Right. Please remember y is remember m is gradient, c is y intercept, right? Just a quick reminder. M is gradient. And the c is your y intercept. Right, these markers are about to die. Let's finish them, right? Right. Azaria, suppose I give you a function looking like this. What does that look like? A quadratic, right? So it looks something like that. Right? So if I want to linearize this, what I could do is I could apply logs, take logs. Sometimes it take logs, sometimes it just take a little rearranging, right? But the first step that we're going to do is taking logs, right? So let's say we have something like this, right? Let's say if we have, y is equal to ax to the power of n, right? As I showed you, if I give you y is 2x squared, that's a quadratic. If I give you 3x cubed, that's something shape cubic, right? But okay with that? So watch here, all right, just watch it for a little bit. Suppose now I wanted to linearize this. So I want it in the form y is mx plus c, right? What you do is you will take logs on both sides. Right, so you will say log y is equal to log a by x to the power of n. Right, and the objective is to take it from here to here. Right, so you take logs here, you have log y. This is log of a product, so you can split it up, right? Are you okay with that? So you can split it up, and you'll get log a plus log x to the power of n. But I still didn't know. Right? Are you okay with that? So you have log of a product and you split it up with addition. Right? Then I can take this power and bring it in terms here. And I'll be left with log of y is equal to, I'll just picture them one time, right? I'll bring in the n here. N log x plus log e. Right? This here has your y. So this becomes a new y. This here has all the x values. So that becomes a new x. This here becomes the gradient. This here becomes the y-intercept. So if I give you values of y and x and you attempt to plot that, you will get curve. Now, if you take your y values and x values and put them in here, right? And you sketch this, that'll be a straight line, right? So when you plot this, it will look something like this. When you plot that, it will look something like this. Log y, log x, and you'll get a straight line. And the gradient of that straight line is n. And the y-intercept is log e. Right? So what we just did is that we took a function that was not a straight line and we made it a straight line by taking logs on both sides. Right? Watch this here. There are two very important things that you need to know. Whenever you're determining a new y-axis, it must never have the constant. So this log or whatever you choose must never have a and n in it. Never. Right? Then it won't be able to plot anything. Because you don't know a and you don't know n. Right? So if you don't know a and n, you can't plot anything. Same thing here. Your x cannot have n and a in it. Right? And then the gradient cannot have x and y in it. And your y-intercept cannot have x and y in it. So when you're separating, your log y or your y could only have x or y. Your x could only have x or y. And a constant m and c could only have the unknown values. All right? That make any sense, Olya? So basically, we're taking this function, y is equal to ax to the power of n, taking logs on both sides, and we put it in the form y is mx plus c. Right? Y and x cannot have the unknown constant. Right? When I finish, I'm going to give you a small note. And then we'll do a question and I'll show you how to work with it, right? Cool already? Note that, all right, insult. It could take a long to the right, but it could take a long to the right. We got that wheel. Yes, ma'am. No, note that. Note that. Right? Use capital letters, right? Note that y and x. Note that y and x use capital letters. Huh? Note that y and x cannot have the unknown variables in them. Note that capital Y and capital X cannot have the unknown variables in them. And second thing, M and C, note that M and C, that's the gradient and y-intercept, M and C cannot have X and Y. Common X and common Y. Common X and common Y. Lowercase. Okay, just make a note of that, right? Whenever you're trying to linearize, do not make sure your y has no constant in it and your x has no constant. Right? So once you figure out this, it means that you're going to log all your y values, log all your x values, and plot a graph. You will get a straight line. And then from that straight line, if you find the gradient, that's it. If you read off your y-intercept, that's your log A. Then you can solve for you. That's okay? Let's just do one more way up to linearize, and then I'll give you some numbers on a graph to draw. So I'm changing it slightly. Number 2, try this please. Y is equal to, well, just give you ax to the power n. Try this, ab to the power of n. Try and linearize that please. A multiplied by b to the power of x. Try that please. A multiplied by b to the power of x. Linearize that. Yes. And let's see what we have here. That's what you all came up with here. Right, so you take logs on both sides, so you'll get log y is equal to log a by b to the power of x. Right? So here will be log y. This is multiplied. So that will be log a plus log b to the x. And then I can take the x and bring it in front, right? So that will be log y is equal to x log b plus log e. Right? Remember, it's looking good. Which one do I choose here for the x? X, I can't choose log a because of variable in it, right? So that this is your x and this is your gradient. This is your y-intercept. That's okay? Are you okay with that? So if I give you values for this, you have to plot log y versus x, right? So your graph would have been log y versus x. Your gradient would have been log b. So your graph would have looked like that. That's okay? Josiah? So I'm going to give you some numbers now, right? And I want you to plot the graph now. So I'm going to give you an equation. You have to linearize, plot the right things, plug the right thing and then find the unknowns. All right, it'll take a little while. Actually, let's play around with one first. No. A little bigger, let's plot a graph. So look at plot a graph. Yeah, on a graph paper. So you need a graph page. You don't have one? Somebody can let me show one, please. And Celine. And Tamia. Oh, you have a graph paper. It happened in the office. $10 someone. Right, log in the group. Log into Zoom and let's take a look at this, right? They gave you a function. I would like you to tell me what A and B. All right. So the function they gave you here is what? The function they gave you is y is equal to AB to the minus x. So step number 1, linearize it. Try your phone. Oh. Right, so the first thing you're doing is linearizing, so you'll know what to plot. That's an x, by the way. Linearize, so you'll know what to plot. Take your time, huh? You gotta put the minus for the gradients. So that time you gotta change anything. So you can take the minus sign and put it with the gradient. Right? If you want, you can take the minus sign and put it with the gradient, right? So you don't have to plot negative x values. Linearize, those who are online, I'd like to know what is your y and what is your x-axis. But let's make sure linearizing good, correct? Trying to finish it. No, hurry up. Hurry. Put the minus sign with gradient, right? Double the button again. Are you sure? Justin, your name not there? Oh, wait, I'm watching the wrong thing. Right? Right? Y, yeah. So you don't have to change the end value. So what does that mean? We are plotting log y versus x. Very good. So you're plotting log y versus x. Right? So those who are online, your linearization should have looked like this. Log y is equal to minus log b by x plus log e. Right? So this is the gradient, this is the x-axis, there's your y-intercept, this is your y. Okay? So watch. Do not change your x values, right? The x value is good. What you have to get? Log y, right? So you have to log all your y values. Try and put it to like 1 decimal, 2 decimal places, right? And then sketch. Here's what I'll help you out, right? According to what the answers have, I'll help you out on the x-axis, 2 centimeters to 1 unit. 2 centimeters to 1 unit on the x-axis. On the y-axis, 1, 2, 3, 4 centimeters to 1 unit here. Right, so can I help you out there? So right, plot the graph and then find the gradient and y-intercept please. It'll take you a little while, so hurry up. I want to do one like this. I want to make sure you'll understand it, right? Anybody confused online? So after you linearize, right? After you linearize, then it lets you know that you're plotting log y against x. So we say see a little mistake. Remember your x-axis cannot have a and b in it, right? Yeah, the x-axis cannot have the constants in it, right? That's what you have to find. Any questions online? Ariane, are you okay? Hey, Kishara, you okay? Yeah, remember to watch the videos and subscribe and thing, huh? Right. No, I think they say I have to reach 1,000. Huh? If you have to use, no, you can double up. That's just the skill that I have in the answer. So you can double up if you want. Right, do it, do your best fit line and tell me what you get for your gradient. And then use it to find A and B. Does it feel nothing really nice? Yeah. Anybody ever got what you understand? The question. No, after that's the given one. Huh? Dapat dulu tuh, cara dulu sama kita. Any answers agreed yet online? Finish the graph. When you plot it, do a best fit line, find gradients, right? Elena, plot your graph. Mia, plot your graph quickly, please. Anybody online? Have a gradient as yet? Huh? Well, remember gradient negative, yes. 0.6. 0 point. Yeah, sounding good. And we will gradient again. Once again. Negative. 2, 4, right? Two all are close, not the exact thing, but I could do. Right, Jaden got negative 0.25. That's the perfect answer. Well, that's the answer I have. Any more answers online there? Kishara, Moses, how much you all got? 2, 1. Close. How come the values so odd? I'm best with line. Well, I have negative 0.25. And what's your y-intercept? Read off as well, right? 2 point? All right. How was your gradient, Zaria? Huh? Right. So according to what I have, right? If you look at it here, the gradient should be how much you get for your gradient. Should be how much you get? How much is that? Correct. You sure I didn't make up that? Let me see your graph.
Actually, you might not see it in textbook analysis. But the analysis.
So everything now there, even the scale and thing. Come, let me take a picture. So I'll send it. Come on, take a picture. Why didn't do your graph? But I gave you the scale to use. All right, so your gradient is negative 0.25, right? And the y-intercept that I have here is 2.3. Based on your best fit line, it might vary slightly, right? Right, now we need to get A and B. Okay, so how do we get A and B? Well, remember we said that the gradient was negative log B was the gradient, right? So of course the minus signs will cancel off. So B is equal to, well, what's the inverse of log? For those who forgot, remember I told you all log is really, LG is really log to the base 10, right? Well, remember that? So really and truly, you're just going to convert to exponential form. 10 to the power 0.25. Well, that's what I have, right? How much is that?
1.7.
Well, mine is 1.8, right? Hello. All right, that's perfect. So you have the exact gradient and exact y-intercept. Nice. And the y-intercept was log A, right? So log A is equal to 2.3. So A is 10 to the power of 2.3. How much is that? 10 to the 2.3 is how much? 199, so that's put 200, right? A is 200. Right? So that's the way you use linearization. That's the way you use linearization to solve these unknowns. Any questions online? Huh? But I know, only know, see all feeling hot. Oh, I know this can make up all in mind. Any questions online there? So my teacher used an E button on the calculator. Oh, your teacher probably used LON on both sides. Right? He probably used LON. Did he like use LN? That's what you meant, or you meant? Oh, okay. Well, if you use LON, then he'll use the inverse of LON, which is E. But LON is not your syllabus. Your syllabus is LON. All right, nice. Let's go in reverse now, right? Are you okay with this? I wouldn't make it plot any more graphs. Right? Some people didn't do it, so. Huh? You okay with this? All right. So suppose I gave you something like this instead, right? So suppose I said, here's what, here's a graph, right? The graph is for log y versus log x. You don't have to plot anything, right? I am giving you the y-intercept. This value here is 0, 2, and I am giving you the x-intercept. This value is 5, 0, right? And I gave you an original equation. Y is equal to a x to the power b. I would like you to somehow find a and b. Take a read. It's on the group. Sorry, no, not on the group. Check on Zoom. I need some ideas there. How we handling that? This time I gave you the graph. I gave you the graph and I gave you the equation. What we going to do to find A and B? Excellent. I'm gonna pick on Josiah. Yeah. What do you think? Oh, he wasn't watching. All right. Huh? All right. Take your time and read it and tell me what you think. How we get A and B? I give you a graph this time and a line with some points. Coming good. Right, so what he said to do is to linearize it. After you linearize it, you will know what's the gradient and what is the y-intercept. And do your thing. Hurry up. Actually, I gave you this one already, right? So you should know what it looks like. Hurry up. Linearize it. And then find A and B. Right, so you do have to draw the graph, right? Right, now go ahead and find B and E closer. What's the gradient? No. I didn't mean that. I meant when you linearize it. Gradient is what? B. And the y-intercept is log A. Right? Tamia? You got that? Right, go ahead. Naisha, finish already. Wait, no. I'm pronouncing his name correctly. And I know the company are pronouncing the names wrong. N-E-I-C-H-E. That's S-H-E. Yeah. That's Naisha. And the next one, Nisha. N-I-S-H-E. So I'm going to convert. Right. Hopefully I'll get it right. Good job, Naisha. Anybody else with the A and B values? Amanda, your values are looking. Oh wait, Suri, check what your sign. Good job, Suri. Amanda, yours good. Naisha, yours good. Jaden, correct. Oshane again, should I? Hurry up, tell me one second again. You can message right here. As soon as I get message here. Elena, are you doing it? Hurry up. No, what are you doing? Huh? So you'll get log y is equal to b log x plus log e. This is your y. This is your x, c, m. Hurry up, find the gradient. Yeah, so yes. So why would I say find a and 6? A and b, yes. So the gradient, when you'll work out the gradient, you'll get minus 2 and 5, which is equal to b. So b is equal to minus 0.4. Your y-intercept is 2. So that means that log a is 2. So a is 10 to the power of 2, which is 100. Are you okay with that? So the first type we did, we drew the graph. The second type we did, right? We obtained the values. We obtained the values given a graph. The third type, I want to see what you all think we're going to do here. I would say these are the hardest type. They're going to give it now. Right? All I want you to do for these here is to linearize. Right? Two most important things are the two steps I gave you here. Right? The y must not have the constant. Right. And the gradient and the y-intercept mustn't have x and y, right? You okay with this? Right? This will always come, but sometimes if it comes, it looks like this, right? Although I saw in 2019 or 18, they make it plotted, right? All right, so let's try the third type. All right, take a look at the board here. Right. Watch what you have here. You have y is equal to ax plus b on x. We have to linearize that. As it is not a straight line, a curve, some kind of curve. I don't know what it is, but it's some kind of curve, right? We need to linearize this. Put it in the form y is mx plus c, right? And the way it looks, can I leave this as my y? Based on the rules? Based on the rules I gave you, can this be my y? Yeah. Can this be my gradient? Can this be my y-intercept? Sorry, the x? Can this be my y-intercept? No, because we have a x. Everything was nice until the y-intercept. So what are we going to do? So we had to figure out what to do. Can we take logs on both sides? Logs on both sides wouldn't simplify that, it'll make it more complicated. What else we can do? We don't want this x here. by x. So Justin said to multiply everything by x. So I'm going to multiply by x. So I'll get xy is equal to a x squared plus b. Huh? But you will still have x and y intercept. But what you say right, you know? Or what you, or what I thought you said right, you know? So watch here. What you say now? Could this be the y? Yes, because it does not have the constant a and b. You're saying that it has x and y, nothing wrong with that, because I'll give you x values and I'll give you y values. So you could find x, y, right? What about here? Gradient, okay? What about x? X squared alone, right? What about here? Yeah, so everything good. So you could plot a graph of x, y versus x squared. And it will be a straight line, y-intercept b, gradient a. Right? So you have to figure out when to use logs and when to just rearrange. Right? It's real simple. The form, the first two I'll give you, that's the only form that you get logs in. And what it looks like this is rearrange it. Like 1, 2, 3 terms, rearrange. Right? Once it's just like the 2 terms I gave you earlier, that's when I take logs. Right? Copy it down. This is the third type. Third type is where you have to rearrange it, right? Any questions online? All I did is I multiplied by x and I made it look like this. Remember, your y-axis cannot have a or b. Your gradient cannot have x or y. Right? So this was going perfect because the y until the y-intercept and this x term and make it back. Right? Shanna? Any questions online there? Amanda? Jaden, are you okay with that? Keshav, you getting through there? You sure? All right, Keshav. This one is for you. Go hard or in between? In between? Wait, why is C so easy? In between? All right, so I'll give you one in between. Not too difficult. A over x. Kind of there. A over x plus b over y is equal to 2. Take your time and linearize that for now. So as you finish, comma, take a look at what you have. Actually, you know, this one have more than one answer. No. One form it clear. Think you have it comma. Remember the y must not have a and b. Region must have a rectangle. And the y. No, same thing for it before my time. Right? Remember, you're trying to linearize it, right? Put it in the form y is mx plus 2. That's a good try. For you. Anybody, any ideas? I see that one up here. Problems. Anybody have anything here? You guys have to try it. I think. Try. All right. Okay, the first thing that it up here, right? First thing to do is remember you want to have the y alone here, right? So move the x to, right? So you have your y, you have your something like an mx, something like this. Then figure out what you will do. Right, so the first thing I would have done is this. B over y is equal to minus a over x plus 2. Right? So if I watch here, the problem here is what? Is it the 1 over the y or the b? What's the problem here? It's b, right? So I get rid of the b. Right? Any problem here? Can I move that a and keep the x there? Is there any x or y here? So the only problem I'm having is this b. You see that? Try it. Let's try to give offer a little bit of help, a little bit of assistance. Then we will see. Let me see what online have here. Online have Naisha, that wouldn't work. I like these in a while. What plenty. All right, time up. Time up. So we have, let's divide everything by b. If I divide by b, I'll get 1 on y is equal to minus a on b by 1 on x plus 2 on b. Right? If I divide by b, b will cancel off. Right? If I factor out the a and divide by b, I'll get minus a on b. If I divide by b, I'll get this. That's okay? So this is your y, this is your gradient, this is your x, this is your c. Right? Almost half that. All right. Instead of 1 over x, x3 minus 1. Yeah. I didn't see that. Sorry, yeah, that? No, what? I know I didn't see it. I just did multiply by 3. Oh, okay. So basically, Sophie, you didn't have it, right? Try this next one here. y is equal to a over x minus b. Try this one. So you see, once you start seeing it two terms, sometimes the other check and see if blocks could possibly work. Probably. May or may not work. Y is equals a over x minus b. Try something. Right, these questions you have to manipulate them, then you will recognize what's the problem, right? So far. Oh, okay. Right. So I just can't understand what the message was. Right. And do you want that? Yeah. I got it. Yeah. Very much. for individual. Right, anything online here? Let me see what you all came up with. Yeah, that could work, Sydney. Tell me what you get for y and x. So good. So we can cross multiply to get rid of this fraction thing here. So that'll be y by x minus b is equal to e. So this is yx minus by is equal to e. So I can just try and switch them around. So I'll get by, I'm moving this here and I'm moving that there. Is equal to yx plus e. Right? So I move the by on this side, I move the a there. Just to make, oh, sorry, minus e. That's okay? So I take the minus by, bring it here. I take the a and bring it here. Right. So let's check and see what could work. What's the problem here? B, right? So let's divide everything by b. So we get in y is equal to yx by 1 over b minus a over b. I divide everything by b. So how this looking? This could work. Let's see. Could this work for y? Yes. Could this work for x? Yes. Could this work for gradient? Could this work for y? Right? Yeah. You have something. A and B. So A is here and B is here.
Yeah. Okay.
Wait, you have 1 on 1. I didn't put my. Right, so I multiply here, make it equal to E. When I reach here, I move across the X. Well, I move this and I move this, right? I divide everything by B because B was the problem. And then, yeah, make that subject. All right, one more here. This one is the hardest of them all. It's the hardest one, right? Anybody have it? Sorry, I was doing. Y squared is equal to A plus BX. Huh? All right, so what's here? This one you have nothing to do. Y squared is equal to BX plus C. And let's implement the square root and rearrange. That's all you have to do. And it's good? And it's good? And it's good here for X?
Yeah.
Gradient and? Huh? Yeah, yeah, it could be anything. Once this variable has x and y in it, it don't matter. It could be cube, 35, it don't matter. All right. Last one, that's it. Last one. So from the textbook, x squared minus y squared is 3x. That's the last one then. Right, let's check out this one here. Those who want on face to face, do it, and then tomorrow edit it. I'll correct it. Take your time. Ax squared minus y squared is 3x. Right, so you don't go too far. This one's about 3 lines long, right? You can do it in two or three. How long is it? It's ready? Don't go too far, about 3, 4 lines. Get someone. Somebody get it, yeah. Somebody in this corner of it. One person have it so far. 2. One person about to get it. To make it 4. Finish it out. What problem is? Huh? You don't want that. So, here it is. Right, let's check out online here. Okay, I've seen a few. Nice, man. I've seen a few answers. Amanda, she type the whole thing. Good job, Amanda. Who else I see in here? Michael, right? Seen a little progress online. Let me see if Kishara will send anything. Tabisha, anything? Ranju? Patel is the last one. I'm gonna hurry up. Bell gonna ring there. For bell ring, let beat the bell. Last one, it's the last one. Not giving you any more. At the end of logs. Right? Next we go to the next topic on the equal. Are you all set up? What was the next topic? All right, so let's see, move across the minus y squared, you get positive y squared. Move across the bx, you'll get ax squared minus bx. It may vary, right? Some people have the ax squared here, nothing wrong with that, right? So from what I have, this is my y, this is my m, this is my x, but my c is a problem. So I am going to divide everything by x. Some people divide everything by x squared, nothing wrong with that. Yours is a little bit different, right? But you'll get the same answer here, right? So we have y squared over x is equal to, the x will cancel, you'll get ax minus b. This is your y, this is your m, this is your x, and this is your c. Just into when you're doing a trans simplifies out, right? They don't look like that. Nice. So